In this video, we're going to take a look at practice quiz number 9, operations with polynomials. Number 1 says to simplify the following expression and write the new expression in standard form. Then we need to name the polynomial by degree and number of terms. So for the first part, I see I have 2 times the quantity x squared minus 3x plus 4 minus 5 times the quantity x squared plus x. So the first thing I'm going to do is start to distribute the 2 to the first trinomial. So I see 2 times x squared would give me 2x squared. 2 times negative 3x would be negative 6x. And then 2 times positive 4 would be positive 8. Then I'm going to distribute the negative 5. So I get minus 5x squared. And then negative 5 times x would be minus 5x. So from there I want to combine like terms. So I see I have 2x squared minus 5x squared, which is going to combine to give me negative 3x squared. Then I've got negative 6x and negative 5x, so those combine to be negative 11x. And then I see I have 8 is by itself as my constant. So then for my standard or simplified form, I see that I just have what I wrote right there. So negative 3x squared minus 11x plus 8. So when they ask for standard form, that's always in order of descending exponent value. So notice I wrote the highest exponent first, which is 2. And then the next one would be a 1, which is understood, and then no exponent on the 8. So that's what they mean by standard form. It's in descending order of your exponents. Then to name the polynomial by degree, the degree of this polynomial is 2 because it always goes with your highest exponent. And so based on the degree of 2, I would name it quadratic. And then number of terms means how many terms do I have separated by plus or minus that I couldn't combine. So I have this first term is negative 3x squared. My second term was negative 11x. And then the third term was 8. So there's 3 terms. So to name it by number of terms, this is a trinomial. All right, so that's it for number 1. Number 2 says factor the polynomial expression completely. So I see that I have 3x cubed minus 24. So first I want to look for a greatest common factor because we should always look for that first when we're factoring. So I see that 3 would divide evenly by 3 and 24 would also divide evenly by 3. But then I can't take x out because the minus 24 does not have an x value. So we would just take out the 3 first and leave that out front. And then what's left over is x cubed minus 8. And then that's 2 terms. So I want to look for a sum or difference of squares, or excuse me, a difference of 2 squares. But I noticed that this is a cube on my x, so that wouldn't work. And then 8 is not a perfect square. So the other way I could factor this would be a difference of 2 cubes. So I see that I do have a perfect cube variable, and I do have a perfect cube number. So I'm going to set up for a difference of cubes type of factoring, which needs a binomial factor and a trinomial factor. My signs are going to be the same as what I started with. So the first sign is negative, like the first one in my binomial. And then opposite of that would be positive. And then the last sign is always positive. So same, opposite, always positive is where we get the phrase SOAP to help us remember our signs. And then we want to take the cube root of the 2 terms that are in the binomial. So the cube root of x cubed would just be x, because x times x would give you x cubed. And so the cube root would just be 1x. The cube root of 8 would give us 2, which we could find in our calculator. If we go to math option number 4, that's where you have the cube root button. And then we've already put the sign in place for that, so that's a 2. And then the pattern is that you want to square the first term in the binomial to get the first term in the trinomial. So that'll be x squared. Square the last term to get the last term, and that would be 4. And you've already got your signs in place. So then multiply these 2 together as they look without their signs. So x times 2 is just 2x, and that goes in the middle. So then this is my factored completely polynomial. All right, let's move on to number 3. It says solve the polynomial by factoring. Show all of your steps to support your answer. So the first step I would do is look for a greatest common factor, because we always want to do that when we're factoring. So greatest common factor, does it have one? So I see that all of these terms have x. So I could take one out, but I can't take more than one because the last term only has one. So let's just take one x out. And then if we divide them all by x, we want to see what would be left over. So these still are equivalent expressions. So I see x cubed divided by x would give me x squared. Negative 2x squared divided by x would be negative 2x. And then negative 3x divided by x would be negative 3. Then that's all still equal to 0, so I'm going to bring that down. Then I want to keep my greatest common factor of x out front. And I see that I have a trinomial that's left. And in this trinomial, a is just equal to 1, so it's the basic kind. So I just need to figure out what two numbers would help me multiply to get negative 3, our c value, and also add up to get the b value of negative 2. So negative 3 times 1 helps me get negative 3 when I multiply. And then negative 3 plus 1 would also help me get negative 2 when I add them together. So I just need to write those in like they look. So x minus 3 and x plus 1 would be my factors. So now I have three factors. I have x minus 3, and I have x plus 1. I need to set each one of those equal to 0 to finish solving by factoring. So I would say x equals 0, x minus 3 equals 0. So then I just need to add 3 to finish solving for x, and I get x equals 3. And then x plus 1 also equals 0, and you just finish solving for x by subtracting the 1. So I end up with 3 solutions. They're all real solutions. And you can easily check this answer with Desmos, is a great thing to do. So let me show you how to do that. So if I type it in, I have x cubed minus 2x squared minus 3x. So notice my x-intercepts should be what I ended up with for my solutions. So I have negative 1, I have 0, and I have 3. So that shows me that I did get the right answers when I factored and solved by factoring. All right, let's look at number 4. We want to divide using the method of long division and then state if 3x minus 2 is a factor of the polynomial. So let's set up for long division. You want to put 3x minus 2 out front. And then underneath put 6x cubed minus 25x squared plus 2x plus 8. And then we start the process of long division. So I'm going to take the first term on the outside and think of what could I multiply in order to get the first term on the inside. So 3x times what would help me get 6x cubed is what I want to think about. So 3 times 2 would help me get 6. And then I have 1x, but I need 3. So I need 2 more x's. So then I'm going to put that at the top of my division bar. That's my first term in my quotient. And then I'm going to multiply that by what's out front and bring both of those terms down. So 2x squared times 3x gives me back 6x cubed. And right there, those should match, which they do. And then 2x squared times negative 2 is negative 4x squared. So then, in this next step, it's very important that you change both signs, because that's subtracting that row of terms. That's what we're doing when we change the sign. And then you can combine your terms. So the first two should always cancel out, because that is our goal, is to get this to reduce. So those should go away. And then you have negative 25x squared plus 4x squared, which is negative 21x squared. Bring down the leftover terms. So we have 2x plus 8 still. And then we just start the process over again. So the first term on the outside, 3x, times what would help us get the first term that's now underneath, which is negative 21x squared. So I'm going to write my thought over here. 3x times what is going to help me get negative 21x squared. That's what I want to be thinking about. So I look at 3 times negative 7 is what would help me to get negative 21. And then x, I just have one x, but I need to get 2. So I need one more x. And then you put this term that you've got, the negative 7x, at the top of your division bar. That's your next term in your quotient. And then that starts the process over again. So we want to multiply by what's out front and bring them both down. So negative 7x times 3x is negative 21x squared. Notice those match, and they should. And then negative 7x times negative 2 is positive 14x. Then you just want to be careful that you change both signs. I recommend you do that in a separate step. Don't try to do all of that in one step. All right, and then we're going to cancel the first two because they should always cancel because this is getting smaller. And then we add what's left. So 2x minus 14x is negative 12x. Then just bring down the 8. Then we start over one more time. So we say 3x, what's on the outside? Our first term out there is 3x. Times what would help us get the first term underneath now, which is negative 12x. So 3x times what is negative 12x. And that would just be negative 4. So that's the last term in the quotient. We multiply that by what's out front and bring both of those down. So negative 4 times 3x is negative 12x, and negative 4 times negative 2 is 8. Then you want to change the signs of both because you're subtracting that whole row. That's why we got to change both. And then the first two cancel out. These last two cancel out, so we end up with no remainder because they just canceled out. So if we have no remainder, first we divided, so part of our answer to this question is the quotient up here at the top. So 2x squared minus 7x minus 4 is half of our answer, and the other half is to state whether or not 3x minus 2 is a factor. And since we have no remainder, that means it divided evenly. So we would say yes, 3x minus 2 is a factor. All right, for the last question, it says for number 5, find the remainder. Use the factor theorem to determine whether x plus 4 is a factor of g of x. Okay, so we can do this two different ways. We can do synthetic division. So let's just use our binomial divisor to put the opposite sign in a box. It's a great method since the a value of that binomial is just 1. So I'm going to put negative 4 in the box. Then I'm going to write down my coefficients of the polynomial and make sure I have all of my exponents that I need. So I start with 4. I have 3, 2, 1, and none. So nothing's missing. I won't need any zeros. So I'm going to bring down the 3. There's an understood 1. And then we have negative 2. Another understood 1, and then 12. Leave rooms and draw a line. Drop the first one down, so I drop down the 3, and then I start my process of multiplying and adding. So 3 times negative 4 is going to go underneath the next number, so that'll give me negative 12, and then I add those together. So 1 minus 12 is negative 11. Then I need to do negative 11 times negative 4 and bring that over. So negative 11 times negative 4 is 44. And 44 plus negative 2 would be 42. Then 42 times negative 4 needs to go underneath the negative 1. So I would have negative 4 times 42 would be negative 168. Then I add 1 plus negative 168 and I get negative 167. Then negative 167 times negative 4 is going to go underneath the 12. I'm just going to grab my calculator to make that a little quicker. So let's say negative 167 times negative 4 is 668. And then I need to add those together. So 668 plus 12 would be 680. And so that is the remainder. So that's part of this question. What is the remainder? It would be 680. Then we would say no, x plus 4 is not a factor of the polynomial because it ended up with a remainder. So the other way we could do this problem is synthetic substitution. So synthetic substitution means you take your divisor of x plus 4 and you get the root that you would get if you set that equal to 0. So if I said set that equal to 0, I get x equals negative 4. And I just need to substitute that for my x value and see what I come up with. So I'm going to plug in 3 times negative 4 to the 4th power plus negative 4 cubed minus 2 times negative 4 squared plus negative 4 plus 12. And then what you get from all of that, and we're just going to type it in the calculator, is the remainder. So it should match what we already found with synthetic division. But it's just another way you can solve this problem. So I'm going to do 3 to the negative 4, 3 times negative 4 to the 4th power plus, gotta be careful, negative 4 cubed minus 2 times negative 4 squared plus, and I'm just going to keep it in parentheses, negative 4 plus 12. So notice I still get a remainder with the same value, which you should. It's just another way to do it. So either method is fine. You do not have to use both unless you just have extra time and want to check yourself. But that is it for practice quiz number 9.